Panos Trahanias from the University of Crete and Foundation for Research and Technology, Hellas, which goes by the name of Forth. And he's speaking to us about robust model-based 3D upper body pose estimation in RGB-D sequences.
So, in the next 10 minutes I will be presenting some of our work that deals with model-based upper body pose estimation in RGB-D sequences. So, we do focus on scenarios and cases where we have free-form human-computer interaction and manipulation. And we're interested in the case that users do arbitrary actions. So we do not want to have constrained cases of users interacting in the scene. We want users to independently, actually multiple users to independently act and interact. And we want by all means to avoid any kind of an initialization phase, which phase we know that is the case in many of the current, mostly skeletonization-based approaches. Such approaches usually cannot handle severe occlusions, so the case of occluding users is usually a problem for these approaches, and as already said, they do require such an initialization. We do want to avoid these two issues, and in order to do so, we have come up with an innovative approach that considers the so-called user top view. Now, this top view is basically a reprojection of the user in the hemisphere that it's above the user, and from the infinite number of reprojections, of user reprojections that one can take, we are interested in the one that is aligned with the main axis of the user. Now, if we consider only the torso of the user, then by taking the main axis of this torso, one can get one and only such reprojection, which we term the user top view. Now, this top view, if we assume a modeling of the user torso as a cylinder, and actually an elliptical cylinder, then this view can be estimated by minimizing a projection ratio, and this ratio is nothing but the number of reprojected points over the total number of the cylinder points. One can very easily verify this, that for the actual user top view, this ratio is minimized for the view that is aligned with the main torso axis. Now, with this concept in mind, one can formulate a methodology whereby after segmenting the users from the scene, we can formulate a hypothesis of the user torso, and by evaluating this hypothesis, one can come up with the actual torso pose. Very briefly, how we proceed. The segmentation part is performed by detecting the faces of the users using a Bayesian skin color detector, and then by taking a reprojection from the top view, one can delineate areas where the users' bodies belong, and in these areas one can search for the point clouds that define the user bodies. Eventually one can end up with this kind of segmentation, and in these segmented point clouds, by using anthropometric proportions, one can delineate parts of the torso and the other parts of the human body. Having this, we formulate an objective function which we minimize in order to obtain the torso pose. This objective function has two parts. a 2D part basically and a 3D part. The 2D part consists of what has already been introduced as the projection ratio, basically the reprojection of the torso point cloud in the top view hemisphere. From this reprojection, one can define the cylinder that defines the human torso. By having the cylinder, one can render the assumed points, and then by comparing with the selected one points, one can have a 3D discrepancy of the assumed torso versus the observed one. So this 3D discrepancy map multiplied by the projection rate can give us an objective function which by minimizing can give us the torso view, the torso pose, sorry. Having done this for the torso, there is nothing that obstructs us from extending this to all the human body parts. For that, we model the human body as an ensemble of cylinders, and we use standard kinematic models for every part. I show here, for example, the kinematic model that defines the human arm, and for this modeling, we assume standard anthropometric proportions in order to have the lengths and sizes of all these human parts. We do this for all the parts, and we define joints across these parts so that we end up with a full human body. With this in mind, I'm going to proceed and show some experimental results. In this first result, we can see a guy acting. So this is the case of a single actor. There is no occlusion. Now we enter the most interesting part where we have users occluding. I'm going to play this once more, so that even in the single user case or in the occluded user case, we can see that we can quite nicely extract the pose of all the human parts. Don't be confused with these markers. These are only for obtaining the ground truth. So this is the interesting case of the abstracting user. Now, this has been tried in lots of scenarios. This is a scenario where we have a number of users interacting with a robot that is sitting behind a bar. This is the bar. Actually, it's a bar that has been set up particularly for this project. And here we show only the results of the torso pose estimation. These are the two estimated shoulders. And this arrow here is the estimated orientation of the body, which is used for the interaction with the actual robot. Having this pose and having the classification of the skin color areas in faces and hands, there is nothing that prevents us from tracking the human body with semantic information regarding face or hands, along with information about possibly manipulated objects. And I'm going to conclude this talk with a longer result that is going to show different cases of either single users acting, users being occluded, and also some comparative results whereby we compare our methodology with the well-known night methodology that is available these days. So again, this is the case of a user, of a single user acting. This is going to be the case where two users, one occluding the other user. We still see that pose can be quite nicely tracked in this case. becoming more interesting right now. This is our reconstruction and post-tracking. This is the night reconstruction. As you're going to observe, our methodology is quite robust in many rather difficult cases. Here we're able to extract the pose of these two guys, night rather face in this case. The third user appears. We're doing quite robustly. So with this in mind, thanks a lot.